This video is about how to convert a complex number into its polar form, trigonometric form or modulus amplitude form, and also how to find theta, which is the argument of the complex number when that complex number or z lies in the various quadrant. Please do watch the full video to get your concepts clear, and if you like the video, please like, comment and share, and also subscribe to my channel. I am Dinesh, you are watching Dinesh Nano classes. So let's start with our class today. Complex plane or argand plane. Let x dash o x and y o y dash be mutually perpendicular lines. As you know, these are known as, this is the x-axis and this is the y-axis respectively. Now, if you write a complex number, now so consider a complex number x plus iy. Now, x plus iy correspond to the ordered pair. Now, if you see, this corresponds to the ordered pair x comma y. Now, this corresponds to the ordered pair x comma y, and it can be represented by the point. Now, this can represent by the point. Consider this, I am representing this as a point P x comma y. Now, P x comma y in the xy plane. Now, this xy plane, this is known as the complex plane or the argand plane, as you can see. The x-axis, now this x-axis, this is known as the real axis, and the y-axis, this y-axis is called the imaginary axis. Okay. Now, the polar form of a complex number. Polar form of a complex number. Now, let the complex number z as x plus iy be represented by a point P. Now, this was a point P x comma y in the complex plane. Consider this like x OP equals theta, and this OP is actually equals r. Then P r comma theta are called the polar coordinates of P. So, this r and theta, now this is the polar coordinates of P. We call the origin as the pole. Now, see, if you look, this is what? This is x, this is y. Now, what is x? If we take this triangle, then x can be written as x equals r cos theta. And if you see this y can be written as r sin theta. So, y is r sin theta. So, basically, the complex number z, this will be represented as r. So, this will be cos theta plus I sin theta. R cos theta plus I sin theta. Now, this is called the polar form, trigonometric form or the modulus amplitude form of a complex number. Here r is what? R is given like r is under root of x square plus y square, is also known as modulus of z. Modulus of z, called the modulus of z, and theta, and this theta is called the argument or amplitude. So, this theta is actually the argument or amplitude of z, and you can write this short as argument of z or the amplitude of z. So, theta is argument of z or amplitude of z. The value of theta, now the value of theta says that if theta lies between minus pi to pi is called the principal argument of z. So, this is called principal argument of z. So, theta lies between minus pi to pi. Now, rules for converting a complex number z x plus iy to the polar form. Now, first of all, let a complex number be given as x is iy be given. Now, we know that x plus iy is r cos theta plus I sin theta. This is the polar form. We also know that x is r cos theta and y is r sin theta. So, on squaring and adding this, so this will be x square, r square cos square theta, y square r square sine square theta. Add them. X square plus y square will be r square cos square theta plus r square sine square theta. You take r square theta common, cos square theta plus sine square theta. This becomes 1. So x square plus y square is r square, or r square equals x square plus y square, or r is under root of x square plus y square. Now see, in order to find theta, we have the following cases. So first of all, in the following cases, we should have a look on this. Okay, now consider this line. Now this is the real axis, this is an imaginary axis. Now see, first is the case 1. When z is purely real means it has only the x part, it doesn't have the y part, then it lies on the x-axis. Now if x is greater than 0, then theta is 0. So basically 0 means this line, so theta will be 0. Now when x is less than 0 means negative, so in this case it will be over here. So this angle is what? Theta will be pi. So theta is actually pi in this case. Case 2. When z is purely imaginary means the real part is 0, it will lie on the y-axis. Then it lies on the y-axis. Now if y is greater than 0 means this. So basically if you take this, theta will be pi by 2. So this theta will be pi by 2. If y is less than 0, then theta is what? Minus pi by 2. So this theta is negative means it is coming over here. So this will be minus pi by 2. Now case 3. First of all, also alpha is an angle which lies between, which is actually an acute angle which lies between 0 to pi by 2. Now consider the case 3 in which we take tan alpha, which is equal to modulus of tan theta. Now what is alpha? Alpha lies between 0 to pi by 2. So these are the cases. Alpha is suppose any other angle than theta. And the relation between alpha and theta is given like this. Tan alpha, that is, will be equals to modulus of tan theta. So see, when z lies in first quadrant, then theta is alpha. Then the angle is directly alpha. So this is alpha in first quadrant. Now when z lies in second quadrant, theta is pi minus alpha. So you have to find theta as pi minus alpha. So this is pi minus alpha. When z lies in third quadrant, so theta is alpha minus pi. Alpha minus pi. So this is in third quadrant, this is alpha minus pi. When z lies in fourth quadrant, theta is just minus alpha. And theta is just minus alpha. So here is the relation between theta and alpha. Tan alpha is modulus of tan theta. You have to take mod of tan theta. And then depending on which quadrant it lies, the z lies, which quadrant z lies, we will decide the value of that argument. Now take some illustration. Represent each of the following complex number in the polar form. Now if you write, suppose this is minus 3. So minus 3 is actually also a complex number. We can write minus 3 as, you see, z, there are actually two questions, minus 3 and minus 2y. First of all, minus 3. So z is what? Z is minus 3. So we can write this as minus 3 plus 0 into I. Okay, now we can take what is z. Z is equals r. You can write this as cos theta plus I sin theta. Cos theta plus I sin theta. Then what is r cos theta? Actually r cos theta is minus 3. R sin theta is 0. So you write r cos theta as minus 3. R sin theta as 0. Again, the process is actually the same. You do squaring and adding. So this will be r square. This r square is actually equals to minus 3 whole square plus 0. Why? Because see, r square cos square theta, r square sin square theta, you take r square common, cos square theta, sin square theta, that will become 1. So basically this implies r square is 9. R square is 9, so therefore r is what? Is 3. Now we will take the positive value only. We have to, in this case, we have to take the positive value. So now, what is cos theta? Now, if you substitute in these values, what will be cos theta? See, cos theta will be -1, and what will be sin theta? Sin theta will be 0. Now, it's actually the same thing. Sin theta is 0, cos theta is -1. So basically, it is a case of a pi. See, this is -3. -3 means it will lie in which -3 is actually the case. Is this the case? So it lies over here, which is actually pi, because x is negative. This is a negative x, -3. And also by this, if you know sin theta, sorry, this is not theta, this is 0, and cos theta is -1, theta is actually pi. So now we have the value of theta. So we can substitute in this. Z is equals, this is 3, this will be cos pi plus I sin pi. So this is the polar form of the coordinate. Okay. The other question was to represent the complex number in polar form. This is -2i. -2i. Now see, z, you can write z as 0 minus 2i. Okay, again, what is z? Z we can write as r, this is cos theta plus I sin theta, or cos theta plus I r sin theta. So what will be r cos theta is 0, r sin theta is -2. Okay, now again squaring and adding. So this r square is basically will become 4, -2 whole square is 4, squaring and adding. So r is basically 2. So now substituting in this, what is cos theta? Cos theta is 0, sin theta is -1. Sin theta is -1, so basically this will give theta to be -pi/2. Now again, if you see, this was -2i, sorry, this was -2i. That means it's in the imaginary number, but in this direction. So if you start from here, this is pi/2. If you go like this, this will be -pi/2. So here argument is -pi/2. So the polar form will be 2, because r is 2. This will be cos -pi/2 plus I sin -pi/2. This will be the polar form.